value of A for which the area of the triangle included between the axis and any tangent to the curve x power A into y equal to lambda power A is a constant is option A half, B 1, C 3 by 2, D 2. We need to find the value of A for which the area of the triangle included between the axis and any tangent to the curve x power A into y equal to lambda power A is constant. Now, let us say this is the curve. At any variable point on the curve, say P, we are drawing tangent to the curve. And it is given that the area of the triangle formed by this variable tangent and the coordinate axis, that is, if the tangent cuts x axis at B and A, y axis at A, then area of the triangle AOB is given to be constant. So, P, any variable of point on the curve, x power A into y is equal to lambda power A. Let us assume it parametrically in terms of a single parameter. Now, we can see lambda power A here and x power A here. So, let me assume x coordinate to be some lambda into alpha, where alpha is a parameter. Now, we have lambda power A into alpha power A into y is equal to lambda power A, or lambda power A gets cancelled and alpha power A into y is 1, or y is 1 by alpha power A, which is alpha power minus A. So, we can assume any point on the curve as lambda alpha comma alpha power minus A. Let us find equation of the tangent at this point. Equation of the tangent at any point x1 y1, we know it is y minus y1, y coordinated P alpha power minus A is equal to m, slope of the tangent is dy by dx at this point. So, partially differentiate this with respect to alpha, y with respect to alpha, x with respect to alpha, dy by dx is dy by d alpha divided by dx by d alpha. So, minus A alpha power minus A minus 1 divided by derivative of x with respect to alpha lambda into x minus x1, x coordinate at P lambda alpha. This is equation of tangent at P, tangent at P. Now, to get coordinates of the point B, y coordinate on x axis we know will be 0. So, let us put y coordinate equal to 0. Once this is 0, minus sign we can see getting cancelled. Alpha power minus A is getting cancelled. So, we are left with 1 here. 1 is equal to minus sign got cancelled, A remains, alpha power minus A got cancelled, alpha power minus 1 remains, that is by lambda alpha into x minus lambda alpha is equal to 1, or x is equal to, throw this lambda alpha by the other side, this lambda alpha goes this side, lambda alpha by A plus lambda alpha, or lambda alpha into A plus 1 by A. X coordinate at B is lambda alpha into A plus 1 divided by A. Similarly, to find point A is the point where the tangent cuts x axis, y axis, and at y axis we know x coordinate is 0. So, let me put x coordinate to be 0. Once this quantity is 0, we can see lambda and lambda getting cancelled, minus sign into minus sign makes it plus sign, this alpha and alpha power minus 1 gets cancelled. So, we have y minus alpha power minus A is equal to, once x coordinate is 0, lambda got cancelled, minus sign got cancelled, A into alpha power minus 1 into alpha minus A, or taking alpha power minus A common, y is equal to alpha power minus A into A plus 1, this quantity it makes it A plus 1. So, y coordinate at this point is alpha power minus A into 1 plus A. Now, we have A, we have B, we want area of the triangle OAB. Area of the triangle OAB is a right angle triangle, half base into height. OA we know it is alpha power minus a into 1 plus a. OB we know it is lambda alpha into 1 plus a divided by a. Now this quantity has to be independent of alpha. This should be a constant. It is given that area of the triangle has to be a constant. So lambda is a constant, a is a given constant, only parameter is alpha. So alpha term in this expansion, in this expression should vanish. Alpha term in this expression should vanish. So alpha term you can see in this expression is alpha power 1 minus a, alpha power 1 and alpha power minus a. This term should vanish. For this term to vanish, alpha power has to be 0 or a has to be equal to 1. For this to vanish, power of alpha should be 0 and a should be 1. So answer is option B. Next question. If f maps R to R is a function defined by f of x is equal to e power x square minus e power minus x square divided by e power x square plus e power minus x square, then option A, f of x is an increasing function. Option B, f of x is a decreasing function. Option C, f of x is onto. Option D, none of these. For the given function f maps R to R, f of x given by e power x square minus e power minus x square divided by e power x square plus e power minus x square. We have to check whether the function is strictly increasing or decreasing or onto or neither of these. So let us see. All through you can see x square. All through you can see x square. Because there is x square throughout, this is a even function. F is a even function. And when it is a even function, there will be symmetry about y-axis. If it is increasing on this side, it will be decreasing on this side. If it is decreasing on this side, it will be increasing on this side. And whenever a function is even, it can neither be strictly increasing nor be strictly decreasing. So option cannot be either A or B. The function can never be strictly increasing or strictly decreasing. So for this particular function, you need not differentiate to check the monotonicity. Directly seeing that the function is even function, you can say the function can neither be strictly increasing nor strictly decreasing. Let us see if it is onto function. You can see this function f maps R to R. F maps R to R, that is codomain of this function is given to be R, and if range is also R, then the function becomes onto. You can see x square is a positive number, minus x square is negative number, denominator e power x square plus e power minus x square is always positive. Now e power x square being positive, e power x square will always be greater than e power minus x square. E power a positive number will be more than 1 and e power a negative number will be less than 1. So this difference is always positive. Because this difference is always positive and denominator is also positive, f of x is always positive. And because f of x is always positive, negative numbers do not belong to range of f of x. None of the negative numbers belong to range of f of x. So that can never make the function onto. For it to be onto, range has to be R, and here negative numbers we can see they never belong to f of x range. So function cannot be onto. So it's option D, none of this. If f of x is equal to 3x square plus 12x minus 1 if x lies between minus 1 and 2, 37 minus x if x lies between 2 and 3, then option A, f of x is decreasing on closed minus 1 to 2. Option B, f of x is continuous on closed minus 1 to 3. Option C, f dash of 2 is equal to 24. And D, f of x has the minimum value at x equal to 2. So, we have to see whether the given function f of x is equal to the given function f of x is equal to 3x square plus 12x minus 1 whenever x lies between minus 1 and 2, and 37 minus x whenever x is between 2 and 3, whether this function is decreasing on minus 1 to 2 or continuous in minus 1 to 3, or f dash of 2 is 24, or whether f of x has minimum value at 2. So, let us see continuity from minus 1 to 3. Minus 1 to 2, this is a polynomial function continuous. 2 to 3, it is again a polynomial function continuous. So, only discontinuity, if at all any, can be at 2. F of 2 is same as f of 2 minus, whenever x is less than 2 and whenever x is equal to 2, we have the same polynomial definition. So, f of 2 minus f of 2 are both equal and equal to, substitute 2 here, 4 3 is 12 plus 24, 36 minus 1, 35. And f of 2 plus, whenever x is greater than 2, f of x is given by 37 minus x, 37 minus 2 is also 35. So, all the three are equal. F of x is continuous on closed minus 1 to 3. Answer is option B. Let us also see why it is not the remaining options. F dash of 2 is given to be 24. F dash of 2 is given to be 24 in option C. We can see right hand derivative at 2 is minus 1. Right hand derivative at 2 is minus 1. So, obviously, f dash of 2 cannot be 24, either the function is not differentiable or derivative will be minus 1 throughout. The function is not differentiable because left hand derivative is positive, right hand derivative is negative, they are never equal. So, function is not differentiable at 2. Let us also see if the function has minimum value at 2. Function has minimum value at 2. F of 2, we found out that it is 35. Right hand derivative is negative. So, to the right side function is decreasing. Left hand derivative is positive. So, to the left side function is increasing. So, this is how the graph would be, and we can see at f of 2 we have a maximum, not a minimum. So, f of 2 there is a local maxima. So, finally, answer is B, option B, function is continuous in minus 1 to 3. Next question, the function in which Rolle's theorem is verified is f of x is equal to log of x square plus ab divided by a plus b into x in closed interval a to b. F of x is equal to x minus 1 into 2x minus 3 in closed interval 1 to 3. F of x is equal to 2 plus x minus 1 whole power 2 by 3 in closed interval 0 to 2, and option D, f of x is equal to cos 1 by x. F of x equal to cos 1 by x is clearly discontinuous at 0. For Rolle's theorem to be verified, we know function has to be continuous in closed interval a to b, differentiable in open interval a to b, and f of a to be equal to f of b. For Rolle's theorem to be verified in closed interval a to b for any function, the function should be continuous in closed interval a to b, differentiable in open interval a to b, and f of a should be equal to f of b. And because cos 1 by x is not discontinuous at x equal to 0, it is not continuous in minus 1 to 1. So, D cannot be our answer. Let us see if C can be our answer. F of x is equal to 2 plus x minus 1 power 2 by 3. X minus 1 power 2 by 3. We have to see whether this function is continuous and differentiable in 0 to 2, and if f of 0 is equal to f of 2. F of 0, put x equal to 0. Minus 1 power 2 by 3 is 1. 2 plus 1 is 3. 2 minus 1 power 2 by 3 is also 1. F of 0 is equal to f of 2. It is continuous function in 0 to 2, but if we see derivative at 1, the derivative left side and right side limits will both be infinite. The function is not differentiable, yet x is equal to 1. We have a cusp. If you see the graph of 2 plus x minus 1 whole power 2 by 3, this is how the graph would be. At 1, the function's value will be tending to 2, and you see a cusp. Left derivative and right derivative, when you evaluate the limits, both of them would be, one would be minus infinity, other would be plus infinity. So, function is not differentiable at 1. So, again C cannot be part of our answer. Let us see if on function f of x is equal to x minus 1 into 2x minus 3, f of x is equal to x minus 1 into 2x minus 3, if you can apply Rolle's theorem in the interval 1 to 3. For that, f of 1 is 0, f of 3 is not 0, f of 1 is not equal to f of 3. So, again Rolle's theorem can't be applied in 1 to 3, though the function is continuous and differentiable, but f of a is not equal to f of b. So, again Rolle's theorem cannot be applied on option B. A satisfies all the three conditions, so answer is A, option A. Next question, let f of x be a quadratic expression which is positive for all real x. If g of x is equal to f of x plus f dash x plus f double dash of x, then for any real x, option A g of x is less than 0, option B g of x is greater than 0, option C g of x is equal to 0, and option D g of x is greater than or equal to 0. Let us see, f of x is given to be a quadratic expression which is positive for all real x. A quadratic, let us say f of x is ax square plus bx plus c. This will be positive for all real x, for all x belonging to R, if and only if its discriminant is negative, b square minus 4ac is less than 0, and coefficient of x square is positive. So, because f of x is given to be greater than 0 for all x belonging to R, we can assume that it is given b square is less than 4ac and a is greater than 0. Now, we have to talk about sign of the function g of x, which is f of x plus f dash of x plus f double dash of x. G of x is f of x plus f dash x plus f double dash of x. This is also a quadratic. F of x is quadratic, f dash x is linear, f double dash of x is a constant. So, g of x is also a quadratic. So, for it to be greater than 0 for all x belonging to R or less than 0 for all x belonging to R, we need to observe discriminant of this quadratic. So, let us see what is g of x. Ax square plus, we have bx here, in f dash x we have 2ax. So, x term would be x into 2a plus b plus constant term here is c, constant term when I differentiate 2ax plus b, and when I double differentiate I will be left with 2a. So, constant term is 2a plus b plus c. Now, this is g of x. Let me observe discriminant of g of x. B square, coefficient of x square is 2a plus b whole square minus 4ac minus 4a into 2a plus b plus c. This would be 4a square minus 8a square minus 4a square b square plus 4ab minus 4ab gets cancelled. Then we have minus 4ac. So discriminant is b square minus 4ac minus 4a square. We already know that b square minus 4ac is negative. We already know that b square minus 4ac is negative. So b square minus 4ac minus 4a square will definitely be negative. From a negative number we are removing another positive number. So this will definitely be negative. Discriminant is negative and coefficient of x square a is positive. So g of x will be greater than 0 for all x belonging to R. So g of x will be strictly greater than 0 for all x belonging to R. Answer is option B. Next question. If f double dash of x plus f dash of x plus f square of x is equal to x square be the differential equation of a curve, and let P be the point of maxima, then number of tangents which can be drawn from P to the curve x square minus y square is equal to a square is. We have to see the number of tangents drawn from the point P to the curve x square minus y square equal to a square. Now x square minus y square equal to a square is a rectangular hyperbola. Now the number of tangents that can be drawn from any point depends on whether the point is outside, inside or on the curve. So based on if x1 square minus y1 square is less than a square, or x1 square minus y1 square is greater than a square, or x1 square minus y1 square is equal to a square, we can decide the number of tangents that can be drawn from the point P to the curve. If x1 square minus y1 square is less than a square, we will have 2 tangents. If the point is on the curve x1 square minus y1 square equal to a square, we have 1 tangent. And if x1 square minus y1 square is greater than a square, we have no tangent. So let us see from the given information. It is given that P is a point of maxima. P is a point of maxima for the curve whose differential equation is f double dash of x plus f dash of x plus f square of x is equal to x square. Now let us assume P to be x1 comma y1. Let us assume P to be x1 comma y1. Our focus should be on x1 square minus y1 square, whether it is less than a square or greater than a square or equal to a square. Now because P is a point of maxima and the function is differentiable, P has to be a critical point and f dash of x at P should be 0. F dash of x at P should be 0. So f dash of x1 is 0. Substituting x1 and y1 on this, f double dash of x1 plus f dash of x1 is 0, f square of x1 is equal to x1 square. F of x1 whole square. F of x1 we know it is y1, y coordinate at the point. So replacing it by y1, we have x1 square minus y1 square is equal to f double dash of x1. x1 square minus y1 square is equal to f double dash of x1. Now P is a point of maxima, and at a point of maxima, second derivative either it has to be negative or it can at most be 0. So it has to be negative or 0, and that makes x1 square minus y1 square non-positive. So x1 square minus y1 square has to be either negative or equal to 0. So x1 square minus y1 square is less than or equal to 0. So x1 square minus y1 square will definitely be less than a square. So we can say the number of tangents that can be drawn from point P to the curve are 2. So it's option A. Next question. if f of x is equal to sin power 6x plus cos power 6x and m1 and m2 be the maximum and minimum values of f of x for all values of x, then m1 minus m2 is equal to m1 be the maximum value and m2 be the minimum value of f of x is equal to sin power 6x plus cos power 6x. m1 is the maximum value and m2 is the minimum value. We need to find the difference m1 minus m2. So, whenever we need to find maxima and minima, don't rush to differentiate the function. See, when you observe sin power 6x plus cos power 6x, you can recollect the formula of a cube plus b cube. So, f of x can be written as a cube plus b cube we know is a plus b sin square x plus cos square x whole. We can write this as sin square x whole cube plus cos square x whole cube. A cube plus b cube is a plus b. A plus b is sin square x plus cos square x 1 into a square x is sin power 4x plus b square x is cos power 4x minus ab is sin square x cos square x. Sin power 4x plus cos power 4x is sin square x plus cos square x whole square minus 2 sin square x cos square x. So, this is 1 minus 3 sin square x cos square x. 1 minus 3 sin square x cos square x. F of x is 1 minus 3 sin square x cos square x. So, this can further be written as 1 minus multiply and divide by 4. 2 sin x cos x is sin 2x. 2 sin x cos x is sin 2x. So, this would be 3 by 4 into sin square 2x. 3 by 4 into sin square 2x. So, for maximum value of f of x, sin square 2x needs to be minimum and minimum value of sin square 2x we know it is 0. So, m1 is 1 and for m2 least value of f of x, sin square x 2x has to be greatest and greatest value of sin square 2x is 1. So, least value of f of x is 1 minus 3 by 4 which is 1 by 4. So, m1 is 1, m2 is 1 by 4. So, m1 minus m2 is 3 by 4 which is option B. So, answer is option B. Next question, A is a set containing n elements and B is a set containing m elements. Find the number of non-decreasing functions from A to B. N elements are there in A, 1, 2, 3, so on up to n, and there are m elements in B, let us say 1, 2, 3, so on up to m. We need to find the number of non-decreasing functions from A to B. We need to find the number of non-decreasing functions from A to B. Now, in this mapping, some or all of the elements of set B may be part of the range, and each element may get mapped to any number of elements. Let us say 1 maps with 2 elements, 1 maps exactly with 2 elements in A, then obviously those two numbers have to be 1 and 2. Now, let us say 2 maps with 3 elements, then they have to be 3, 4 and 5. So, we need to see how many elements gets mapped with 1, let us say x1, how many elements gets mapped with 2, let us say x2, how many elements get mapped with 3, let us say x3, so on up to how many elements get mapped with m, let us say xm. Once we decide how many elements are getting mapped with each one of these elements, automatically, because we know function is a non-decreasing function, we start mapping from the first element and keep completing the mapping. So, the number of different mappings from A to B are nothing but the number of non-integral solutions of the equation x1 plus x2 plus x3 plus so on up to xm is equal to n. The number of different solutions of this equation will be same as the number of different possible non-decreasing functions from a to b. So, we all know from permutation and combinations that the number of different solutions of the equation x1 plus x2 plus x3 so on up to xm is equal to n. The non-negative integral solutions are n plus m minus 1 c m minus 1 or n plus m minus 1 c n. So, answer for this question is n plus m minus 1 c n, which is option A. Next question. Let A be the point where the curve 5 alpha square x cube plus 10 alpha x square plus x plus 2y minus 4 equal to 0 meets y axis. Let A be the point where the curve meets y axis. Then the equation of tangent to the curve at the point where the normal at A meets the curve again is. Then the equation of tangent to the curve at the point where the normal at A meets the curve again is. The curve is given to be 5 alpha square x cube plus 10 alpha x square plus x plus 2y minus 4 equal to 0. Let A be the point where this curve cuts y axis. Let A be the point where this curve cuts y axis. At this point, we are drawing the normal, and if the normal cuts the curve again at point B, we need equation of the tangent at the point B. We need equation of the tangent at the point B. So, A is a point where the curve is cutting y axis. For a point on y axis, x coordinate is 0. Putting x equal to 0, all this is 0 and y is equal to 2. So, A is the point 0 comma 2. A is the point 0 comma 2. Let us find equation of normal at A. For normal at A, we know the point. Equation would be y minus y1 is equal to m into x minus x1, where m is slope of the normal or minus dy by minus dx by dy. Minus dx by dy. Differentiate this and simultaneously put x equal to 0 and y equal to 2. Derivative of this is 3x square, and at x equal to 0 it becomes 0. Derivative of this is 2x, and as x is equal to 0 this becomes 0. Derivative of x is 1. 2 dy by dx is equal to 0, or dy by dx is equal to minus 1 by 2. dy by dx is equal to minus 1 by 2. So, minus dx by dy will be equal to 2. Minus dx by dy will be equal to 2. So, equation of normal is y minus 2 is equal to 2x. Y minus 2 is equal to 2x. So, to find the point B, let me solve the normal at A, that is y minus 2 is equal to 2x with the curve again. Let me solve y minus 2 is equal to 2x with this curve. So, wherever you see y minus 2 in this equation, replace it by 2x. This equation becomes 5 alpha square x cube plus 10 alpha x square plus x plus 2 into 2x, which is 4x, or that makes it 5x equal to 0. So, one solution for this, we already know it is 0. So, x equal to 0, we can remove it from the solution list, and 5 we can cancel it throughout. So, we have alpha square x square plus 2 alpha x plus 1 is equal to 0, or we have alpha x plus 1 whole square is 0, or x is equal to minus 1 by alpha. X equal to minus 1 by alpha. So, this is the point, B is the point where x coordinate is minus 1 by alpha. We have to find y coordinate. Y coordinate is 2x plus 2. This point is a point on this line, normal at A. So, y coordinate is 2x minus 2 by alpha plus 2. Let us find tangent equation at B. Tangent equation at B. For tangent equation, we need to find slope of the tangent at B. Slope of the tangent we get it by differentiating the curve dy by dx. So, equation of the tangent is y minus y1, y minus 2 by alpha, y plus 2 by alpha minus 2 is equal to m into x minus x1 1 by alpha, and to find m, let us differentiate this curve. So, derivative of x cube is 3x square, x square is 1 by alpha square, 1 by alpha square gets cancelled, we have 15 plus 10 alpha into 2x, 2x is minus 2 by alpha, so this is alpha gets cancelled, minus 20 plus x, derivative is 1, plus 2y, derivative is 2 times dy by dx, which is our slope, is equal to 0, or dy by dx from here we can see it is minus 5 plus 1 minus 4, 4, 2. dy by dx is 2. So, equation of the tangent is y, 2 by alpha gets cancelled, minus 2 is equal to 2x, or it is 2x minus y plus 2 equal to 0, option C. Answer is option C. Next question, if alpha is the only real root of the equation x cube plus bx square plus cx plus 1 equal to 0, where b is less than c, then the value of tan inverse alpha plus tan inverse 1 by alpha is equal to option A minus pi by 2, option B pi by 2, option C 0, option D cannot be determined. It is given that alpha is the only real root of, this information is very important, it is the only real root of x cube plus bx square plus cx plus 1 equal to 0, where b is given to be less than c, and we need to find the value of tan inverse alpha plus tan inverse 1 by alpha. This question, the options are very tempting, and usually students are prone to make a mistake of writing tan inverse 1 by alpha as cot inverse alpha, and tan inverse alpha plus cot inverse alpha is pi by 2. But remember, tan inverse 1 by alpha is cot inverse alpha if and only if alpha is positive. If and only if alpha is positive. And when alpha is negative, tan inverse 1 by alpha will be minus pi plus cot inverse alpha. Minus pi plus cot inverse alpha if alpha is negative. So, tan inverse alpha plus tan inverse 1 by alpha will be either tan inverse alpha plus cot inverse alpha pi by 2, or minus pi plus pi by 2, which is minus pi by 2, if we are able to say whether alpha is positive or negative, from the given information. So, our focus should be on checking whether alpha, the only real root of this equation, whether it is positive or negative, whether it is positive or negative. Now, when alpha is the only real root, the other two roots have to be imaginary. The other two roots have to be imaginary, and b less than c indicates b and c are real numbers. So, the other two real imaginary roots, one has to be conjugate of the other. So, the three roots of this equation, let they be alpha, beta and conjugate of beta. Beta and beta bar should be conjugate pairs. Imaginary roots, whenever they occur in conjugate pairs. So, roots of this equation are alpha, beta, beta bar. Observe product of the roots alpha into beta bar. Beta into beta bar. Any complex number beta, if it is x plus iy, beta bar would be x minus iy, and beta into beta bar is x square plus y square mod beta square, which will always be greater than or equal to 0. So, beta into beta bar is always greater than or equal to 0, and product of the roots alpha into beta bar is minus 1. For a cubic equation, product of the roots is given by minus of constant term done by coefficient of x cube. So, alpha beta bar is equal to minus 1. Beta bar mod beta square is always positive. So, alpha has to be negative. So, from this we can conclude that alpha is negative, and as alpha is negative, tan inverse 1 by alpha will be minus pi plus cot inverse alpha, and because tan inverse 1 by alpha is minus pi plus cot inverse alpha, answer would be minus pi plus pi by 2, which is minus pi by 2. So, answer is option A, minus pi by 2. Next question, let alpha, beta and gamma be the roots of f of x is equal to x cube plus x square minus 5x minus 1 equal to 0, then integral part of alpha plus integral part of beta plus integral part of gamma is equal to. It is given that alpha, beta, gamma are roots of the equation f of x is equal to x cube plus x square minus 5x minus 1, x cube plus x square minus 5x minus 1 equal to 0. We need to find integral part of alpha plus integral part of beta plus integral part of gamma. Alpha, beta, gamma are roots of this equation, and we are supposed to find integral part of alpha plus integral part of beta plus integral part of gamma. To say what is integral part of alpha, we need to know between which two consecutive integers alpha lies, and to talk about integral part of beta, we need to know between which two consecutive integers beta lies, and to talk about integral part of gamma, we need to know which two consecutive integers gamma lies. Now, let us see if we can find roots of this equation by inspection or some information about between which two consecutive integers these two roots lie by hit and trial. F of 0 is minus 1, f of 1 is 1 plus 1 minus 5, which is minus 4, f of 2 8 plus 4 12, minus 10 2, minus 1 1. We can see f of 1 is negative and f of 2 is positive whenever a continuous function is changing from a negative number to a positive number. There should compulsorily be a root between 1 and 2. So, there should compulsorily be at least one root between 1 and 2, or there should compulsorily be odd number of roots between 1 and 2. So, it is possible that 1 of alpha, beta, gamma is between 1 and 2, or all of alpha, beta, gamma are also between 1 and 2. So, let us keep our investigation. Let us move towards f of minus 1. F of minus 1 is minus 1 plus 5 minus 1, which is 4. We can see minus 1 is positive, f of minus 1 is positive, and f of 0 is negative. So, again between minus 1 and 0 there has to be a root of f of x. Now, we have located two roots of f of x. One root is between 1 and 2 and another root is between minus 1 and 0. And as x tends to minus infinity, f of x tends to minus infinity. So, obviously there should be a sign change towards this side. So, let us keep moving. F of minus 2. F of minus 2 is minus 8 plus 4 plus 10 positive. F of minus 3 minus 27 plus 9 minus 18, minus 18 plus 15 minus 3 minus 1 is negative. So, we can see f of minus 3 is negative, f of minus 2 is positive, there is a sign change, and for a continuous function there should at least be a root whenever there is a sign change. So, we can see between minus 3 and minus 2 there will be a root, between minus 1 and 0 there will be a root, and between 1 and 2 there will be a root. Without loss of generality, let alpha be here. Integral part of alpha is minus 3. Let beta be here. Integral part of beta is minus 1. And let gamma be here. Integral part of gamma is 1. So, answer is minus 3. Integral part of alpha plus beta plus integral part of gamma is minus 3. Answer D. Next question. Let f of x is equal to 1 plus x into sin x into integral part of cos x, where x lies between 0 and pi by 2. Option A, f of x is continuous in 0 to pi by 2. Option B, f of x is decreasing in 0 to pi by 2. Option C, f of x is increasing in 0 to pi by 2. And option D, f of x has local maxima in 0 to pi by 2. Now, observe the function f of x is equal to 1 plus x into sin x into cos x, and this function is defined in 0 to pi by 2. And whenever x lies between 0 to pi by 2, cos x will lie between 0 to 1. As there is no equality here, it can't be 1, it will be in open interval 0 to 1. Open interval 0 to 1. And at pi by 2 also this is 0. So, cos x lies between closed 0 to open 1. And integral part of cos x thereby is 0. Integral part of cos x for all values of x between 0 to pi by 2 is 0. So, f of x is equal to, as this is 0, we have a simple constant function 1. We have a constant function 1. And a constant function is not strictly increasing. A constant function can't be strictly decreasing. A constant function has no local maxima or local minima. So, only possible option is f of x is continuous in 0 to pi by 2. Its answer A.